At the edge of an international border, at the edge of the Pacific, at the edge of innovation, community, education, and discovery, you're listening to At the Edge of It All, a University of San Diego podcast where USD experts speak on topics and stories that impact you and the broader community.
Hi, I'm Alyssa Martinez.
And I'm Elena Gomez.
And in this episode of At the Edge of It All, we speak with integrated engineering professor Gordon Hoople, who talks to us all things engineering and his love for the arts.
That's right. He is in the discipline of integrated engineering, so he tells us a little bit more about how he got interested in that and how it's so important to have a multidisciplinary approach in engineering today. Let's take a listen.
Well, Gordon, thank you so much for joining us on the podcast today. We're going to dive into the world of integrated engineering, what that means. It's kind of a interesting and unique program here at the University of San Diego, but we'll talk about it in a little broader context of what it means for just about anybody, even if you're not in engineering, what it can mean for the future here. But would love to talk a little bit background-wise of what got you into engineering. Everyone has a cool story of how they got to where they were, so we'd love to hear yours.
Yeah, so when I was a kid, I did this program called Odyssey of the Mind, which was this really interesting, they give you a challenge and you worked on it kind of outside of school with a group of 5 or 6 or 7 people. And it had both kind of technical elements and artistic elements. So you had to create a skit that answered some problem and you had to solve a technical problem as a part of it. And so I did this for many, many years, elementary school, middle school, and it was a really big part of my life. It was like my biggest extracurricular activity for a long time. And that's really where I got interested in engineering. There was one of my best friend's parents growing up, was this self-taught engineer. And he taught me so many things about engineering and got me really excited about it. But it was always in context. It was always in the context of, well, how does this serve the larger kind of play that we're putting on? Or how does this respond to the challenge that we've been posed? So we actually went to the World Finals one year and won, which was amazing.
Wow.
It was through this program. It was a program about Shakespeare. And so we had to adapt the Shakespeare play. And we built this amazing kind of, I guess it was like a trapdoor slot machine that kind of fit into the story of our overall skit. And it was just a really fun experience. And I think I've just been doing that my whole life ever since. Everything I've done, the way I went to grad school had this very integrated aspect where I was doing both engineering, but other things too. Now here at the University of San Diego, integrated engineering is bringing all of that stuff together as well.
Well, what I think it's cool is that what I've learned from being here at the university for a few years now is the integrated part of everything that we do, right? Like so many schools now kind of work together in various projects. I remember I was working with a professor in the College of Arts and Sciences who was a poetry professor who was partnering up with a biology professor at a local middle school, and they had to create a poetry book that explained some sort of biology. Like that kind of stuff is really cool, and that's what attracted you, as I can see.
Yeah, absolutely. I mean, I came to the University of San Diego for the reason of building this integrated engineering program. It was what attracted me here. The fact that we have, faculty and staff and students that are interested in the intersections, right? This intersectionality of all these different ideas. It's what makes this place so special, I think.
So let's talk about what is integrated engineering.
Yeah, so integrated engineering is a department that we started about, I guess it's 7 years ago now. And we've always had a BSBA degree in the engineering school here. So students have to take a lot of liberal arts classes and they have to take a lot of engineering classes. And it's actually a 4.5-year degree program, which some students are surprised to find out when they get here. But we try and make it obvious.
Surprise, surprise.
And so we've always had this philosophy that it's really important to bring the liberal arts alongside the engineering education. But what we wanted to do with integrated engineering was really bring them inside the engineering classroom itself. So really trying to design engineering courses that draw from not only different fields of engineering, but also draw from areas outside of engineering. So looking at places like what could we learn from sociology, or what could we think about from the arts, and trying to draw that into the engineering classroom.
Why? What's the benefit as you see it?
We think it makes better engineers. So engineering, if you ask people that have just graduated from engineering school, what do you wish you'd studied more of? The recent grads say, I wish I'd taken this one technical elective in my area. And then if you ask people maybe 5-10 years out as they're starting to be managers, like, I wish I'd taken a class in the business school. Then you ask people 15-20 years out, they say, well, really wish I'd taken that philosophy class. So I better understood the problems I was trying to solve. Because engineering at the end of the day is about helping people solve problems. That's what we do as engineers. And so we use tools of science and technology to do that. But if you don't understand what the problem is that you're trying to solve and the way that your solution fits into society on the whole, you're not going to make the right choices. You're going to make decisions that have negative impacts on the world. And we've seen that. Or you look at, for example, climate change. right? So back in the Industrial Revolution, engineers came up with this technology and like, oh, look, this is great. This solves this really important problem. We now have these machines that can start doing things that people couldn't. And we've seen this rapid rise in kind of life expectancy and all these other good things. But at what cost, right? This unexpected discovery of, oh, look, we're also radically changing the environment in ways that we didn't anticipate. And so we think that the engineers of the future need to really be able to understand those problems and think about how they're going to not only bring their technical skills to bear, but also bring all of the understanding of how the world works into their problem-solving process.
Can you give us an example of what integrated engineering would look like if you were to take a class, one of your classes? What would that actually look like?
Yeah,
Or a project even.
A project, yeah. So I've got, so I think maybe one of my classes that's a good example of this is a class that I developed with my colleagues called Integrated Approach to Energy. So even from the very way we developed it, it was 4 faculty working together who had 4 very different backgrounds from engineering. So we had me in mechanical engineering, we had a civil engineer, Dr. Diana Chen, Dr. Susan Lord, our electrical engineer, and Dr. Alex Mejia, who's an engineering education expert. And so the 4 of us worked together over the course of 2 years with a grant from the National Science Foundation to kind of put this class together. And it takes a kind of holistic look at how do we use energy and how do we generate energy, right? And kind of thinking about the ways that energy flows through our economy, through our society. And so the class, one kind of example of how we structure the class is thinking about electricity generation here in the state of California, right? How do we make electricity? And so we'll do things like talk about, okay, well, how does a wind turbine actually work, right? And so look at we need to know the diameter of the rotor and what the wind speed is, and there's these statistical models. But then we ask questions like, and where should we put them, right? And who will feel what way about where they get placed, right? And so we look at kind of the impact on communities of having those kinds of technologies sited near them, and talk about the social challenges. We talk about the legal regulatory framework that kind of companies have to deal with as they're putting these new energy technologies into place.
How do you see students tackling this class?
They really, really like it. One of my favorite things about teaching that class is that students kind of come in and a lot of them don't know very much about the topic. And as the semester goes, I see them getting more and more engaged, more excited, more interested, to the point where I've had students kind of come say, well, I came in thinking I was going to do this as my area of interest, but I really want to change and focus on energy. And so we've had a lot of students now who have kind of gone on and really pursued that as an area of interest for them.
Now, one question I have is that, things are not always rainbows and butterflies, especially when you take different disciplines, different people, and bring them together. I mean, group projects, I used to hate them in college, but obviously you do a lot of that in real life, in the real world, when you get to work and other places. How do you guys manage working together in projects? The student side of things, but also you as a professor, right? How do you manage working with other professors from other disciplines? I'm sure all of you are very passionate about what you do. I mean, do you guys have heated discussions? How do you work around those things? Because people are so adverse nowadays, I think, of getting outside of their comfort zone and collaborating sometimes.
Yeah, this has been a big area for me, is working across disciplines. So I work with a lot of different people around the university on different projects. One of the things I do is I run an art collective, and we have the 4 kind of leaders of the group are me in engineering, a professor from theater, Nate Party, professor of mathematics, Diane Hoffus, and a professor from the Peace School, Austin Troy Fitzpatrick. And so the 4 of us, as you might imagine, don't always agree on what to do. I remember one particularly funny story. We were working on very early installation, and I was talking to Diane Hoffus, and she said, well, I want it to be straight up and down. I was like, great, well, I'll put it a little bit of an angle like this and it'll be perfect. She's like, no, when a mathematician says straight up and down, she means 90 degrees. It's perpendicular to the ground, right? I was like, oh, okay, well, that's not what we mean in engineering. We just mean basically upright, but sure, okay. Right. And so there's always kinds of little interesting things.
And then there's a Peace School professor, Troy Fitzpatrick, who has his ideas, right?
Yeah, and so we're always kind of getting interesting debates and interesting kind of questions and thinking about things. One of the things I love about working with that group is just all the different ideas that people bring.
So how do you do the give and take?
It's a lot of listening. I think the thing that we do well is we kind of make space for everybody to share what they're feeling, what they're thinking about. And the collective itself now we have about 30 people that ranges from students to people from the community to the faculty that are here involved in USD. And we try and create space for everybody to kind of share what they're thinking about, because we really believe that the best ideas come from having lots of different perspectives.
I know we've talked to Professor Hafiz and Troy Fitzpatrick in other episodes, but for those who may not have listened to that, can you go a little bit into your art collective? Because it seems like it's like a bigger, better version of what you used to do when you were in elementary school.
It really is. Yeah, it really is. I was thinking about that the other day. So the art collective, we made large interactive artwork that is designed to kind of get people to stop, smile, and engage. And so we've taken that work to here in San Diego. We've done installations at public parks up in La Jolla. We've also been to Liberty Station. We've done the WOW Festival that was up at UCSD last year. It's actually there again. If you're in San Diego, I definitely recommend checking it out this year. It looks like it's going to be really cool. We've also taken the works to Burning Man, so done kind of large installations out in the Nevada desert. And we have a permanent installation that's coming in the city of Escondido, which will be our first permanent installation pretty soon here.
Oh, cool.
I'm interested to see what the world of engineering looks like once students graduate. You kind of talked a little bit about, the classes that they wish they would have taken as they get further and further out. Are you seeing that engineering is becoming more integrated in the sense of like engineers will, and I'm thinking also of the introduction of AI, right? Of all these different things. How important will it be to have a broader mindset and not just such a niche in engineering? Do you think that's important?
Yeah, I think that one of the things that we've always felt with integrated engineering in particular, but engineering education more broadly at USD, is you really want to create students who can think like engineers. The technical skills that we're teaching them, maybe they'll use those when they go to their first job, maybe they won't. But what we're really doing is trying to get them to think and understand and how to problem solve and think critically. And I think with AI, that's even now more important than it has been in the past, because you're going to learn on the job whatever particular technical thing you need to know, right? So, I can teach my students in this energy class something about energy, and they may or may not ever use anything I actually teach them in that class in their actual job. But the skills about how they approach a problem and the skills about how they think about the context around what they're doing are critically important. And so I'm really seeing the importance of that as, our problems aren't getting simpler. We have really, really complicated problems that have all of these networked effects right now. And I think that's the big challenge that's going to be facing this next generation of engineers.
Yeah, I mean, the topic of energy is not an easy one to tackle. And I think, as you said, more and more diverse opinions, points of views, and backgrounds are only going to elevate, I think, the number of possible solutions to something like that.
Absolutely.
Well, Professor Hoople, thank you so much for joining us. This was really insightful and I think so interesting to dive a little bit deeper into what the world of integrated engineering looks like today. So thanks for being with us.
Thanks for inviting me. It's been a pleasure.
And if you like this episode, be sure to subscribe to catch our next one.